Hello all. So today we are going to see about the basics of thermodynamics. Initially we are going to see about what is thermodynamics. So thermodynamics is derived from the Greek word thermo means heat and dynamics means heat and motion. So basically thermodynamics is a subject relation between heat and motion. So how heat is converted into work and work is converted into heat. So that is a topic we are going to see in this basic syllabus. So basically thermodynamics is of two types. One is classical thermodynamics and another one is statistical thermodynamics. So classical thermodynamics deals with a macroscopic approach and statistical thermodynamics deals with microscopic approach. So what is macro and micro? So as the name indicates, macro is a study of overall properties of a system and micro is a study of individual properties of a system. That is so let us take a duct as an example and let us say we are going to check the pressure of this particular instant and a gas is flowing inside this duct. So this gas may be air or any gas as you consider or any fluid. So how do we define a pressure? First initially. So pressure is nothing but force per unit area. So whether the pressure is a macroscopic quantity or a microscopic quantity, that is a basic question which will arise for any beginners. So initially, so this gas molecules contains many migrates of molecules. So what is initially pressure? Which is felt as pressure? So the collision of each molecules at this particular area is felt as pressure. So if we go to study the overall behavior of the molecules, then we call it as macroscopic quantity, and if you go to study the individual collision of particles, it is called microscopic study. So this is the basic of thermodynamics, and we are going to study the classical thermodynamics, which is macroscopic approach. So we don't consider in any system the study of individual molecules. We study the overall behavior of the molecule. So this is the basic difference between microscopic and macroscopic approach. So in thermodynamics we come across three major definitions, that is system, surrounding, and number three is boundary. So what is a system? So let us take an example of steam power plant. There are four main parts of a steam power plant, that is boiler, turbine, condenser, pump. And I believe that the basic science, in basic sciences you would have known about what is boiler, turbine, condenser and pump. So boiler is a device which is used to change the water into steam, that is the inlet of the boiler will be a liquid form and exit is vapor, and again this high pressure vapor is expanded in a turbine, and again the phase change is there is no phase change, it is again vapor, but entry level it is high pressure vapor and exit level it is low pressure vapor. So condenser is a device which is used to reject heat, that is reject the latent heat, and it is used to change the phase of the flowing fluid, that is vapor. So from vapor to liquid conversion, and again this pump is used to pump the liquid into the boiler. So this is the basic four main parts of the steam power plant. And here, with this help, we are going to see what is system, what is surrounding, and what is boundary. So let us consider an in charge, that is, I say, let me be the in charge of this whole power plant, and I assign four persons. Example, Arun Kumar, Dilip, Ayandurai, and Akil. These four as the maintenance in charge of the particular part of the power plant. So this boiler belongs to Dilip, this turbine belongs to Arun, and this condenser belongs to Akil, and this belongs to Ayandurai. So basically, and I am the whole in charge of this power plant. This is Damodharan. So I am the whole in charge of this power plant. So what is the system? So system is a device which is under the study. Example, if I am the in charge of this whole power plant, I am the in charge of boiler, I am the in charge of turbine, I am in charge of the condenser, I am in charge of the power plant. So I am investigating the whole power plant, and this whole power plant becomes my system. So this is a system, right? So if Dilip is deputed to work in this boiler, this particular boiler. So this boiler becomes his system, and rest from the boiler becomes his surroundings, right? So likewise for Arun, this turbine alone becomes his system, and everything apart from the system becomes his surrounding. And for Akil, this condenser becomes his system, and everything around this becomes surroundings. And Ayandurai, for pump is going to be the system, and everything apart from the pump is going to be the surroundings. So this is the basic difference between a system and a surrounding. So what is system? System is a device which is under consideration, under our investigation, right? So that is this is the best example for that. So surrounding is apart from the system which we consider. Then apart from the system, everything becomes our surrounding. Example, I am in charge of this power plant. So this this boundary line shows that I am going to investigate only this. So this becomes my system, and everything apart from the system is going to be my surroundings, right? So what is boundary? So boundary is nothing but is boundary which is going to separate the system and surrounding is known as boundary. This boundary can be fixed boundary or a moving boundary. So in case of a closed system, we call that system to be a fixed boundary system, and it's a moving boundary system. And for open system, it is a closed system. So example, so now we tend to study about different types of systems. So first we have seen what is system, surrounding, boundary. Now what are the types of system? So system is basically classified into three types. That is an open system, that is a second one is a closed system, and third one is isolated system. So what is an open system? So in open system, let us consider this body A as a system, and this is the boundary, and everything apart from it is a surroundings. So in an open system, there is both mass flow and there is also energy flow. If there is both mass flow and energy flow, that system is considered to be an open system. If there is, so we consider this as a system A or B. If there is only energy transfer and there is no mass transfer, then such type of systems are called closed system. So in isolated system, there will be neither mass transfer nor energy transfer. So such type of system are isolated system, and this system is just an imaginary system. So in our practical application like boiler, turbine, and many other engineering applications, we only come across open and closed system.
I have doubts, sir. So what is the real-time application for open system and closed system?
So real-time applications is very good question. we take a piston cylinder arrangement. So this system is closed, right? This is let us consider this system is closed, and there is a crank and connecting rod, and this is a piston, right? So here, if we tend to compress the gas, if you tend to compress this gas or expand this gas, so what is going to happen? So there is a gas of mass m. So if you are going to compress the gas, there is no mass transfer because this is a fixed vessel. So there is no mass transfer. But as we compress, the pressure and temperature of the system is going to increase. So when there is a temperature T1 inside the cylinder, and this is an ambient temperature T2, when T1 is greater than T2, then there is a heat flow from inside the system to outside the system. So hence we call there is an energy transfer here in form of heat, and there is no mass transfer. Hence we call this system to be a closed system. So here in open system, whereas in open system, example, we take a boiler. So boiler is a very good example for an open system. So inside the boiler, there will be liquid will be pumped inside the boiler, and there will be steam will be emanating from the boiler. So this is in the vapor form, right? So this is a system where there is a mass entry in form of liquid, and there is mass exit in form of vapor, and there is also what? Heat transfer. So we are supplying some heat to the boiler. So here there is both mass transfer and there is both what? Heat transfer. So hence we call this system as what? As a open system. That's all.
Thank you, sir.
Thank you. Thanks. Damodharan.